For this part of our lesson, we're going to look at quadrilaterals. Quadrilaterals are two-dimensional figures that have four sides and four angles. And when I say they're two-dimensional, that means they're flat. Three-dimensional means they're like real things, real people with three dimensions. But these are two-dimensional, so something you would draw on a sheet of paper. So, I just want to let you know just some definitions of some words and how those kind of go together. Once we get these geometric terms in our brains, then we're going to start looking at some measurements and how we measure them and that sort of thing. So the first one I wanted to look at today was parallelogram. A parallelogram has opposite sides that are congruent and parallel. When something's parallel, that means they never touch. They go along the same plane and they never cross. They never intersect. So if they are parallel, the opposite sides are both parallel and congruent, the same length and parallel. I wanted to just show you some marks today. As I'm seeing some lessons, I'm not sure that everyone's solid on this, so I just wanted to make sure. When you see little dash marks or things on any kind of geometric shape, it means they are equal. So this is a 1 dash and a 1 dash, so those two sides are the same. They're congruent. And when this has a double dash here, those two sides are congruent. So they measure the same. So this is a parallelogram. If you stretch these lines out forever, they would never intersect. And if you stretch these out forever, they would never intersect. So it has two sets of parallel lines. A rectangle is simply a parallelogram with four right angles. And that right angle, again, is 90 degrees. And it's that straight looking like 3 o'clock and 9 o'clock on the clock. And so this is an example of a rectangle. Again, you see the single dash marks here. That means these sides are congruent. And the double dash means it's congruent with this other double dash. In the corners, I showed you this, I believe, in the triangles before, is a little, it squares it off basically. You see a little line. When you see that squaring off a corner, that means it's a right angle. It's 90 degrees. A right angle, a right angle. Again, it looks like an L or a backwards L, something like that. And you can see that in these corners. And that is a rectangle. Again, a rectangle is a parallelogram with four right angles. This is a parallelogram, simply parallelogram. It does not have any right angles. That's the difference of those two drawings. The next quadrilateral I want us to look at is a square. A square is simply a special parallelogram. It has four congruent sides and four right angles. Now the difference between the square and the rectangle had only two congruent sides, these two and these two. Whereas on this one, the markings are all the same. 1 dash, 1 dash, 1 dash, 1 dash. That means all those sides are the same. So that shows the four congruent sides. And then again, in the at the angles, if you see this little squaring off, that means it is a right angle. So this drawing has four right angles and four congruent sides, so it is a square. That's the definition of a square. Now, a rhombus is a special parallelogram. It has four congruent sides, just like a square, but it doesn't have the right angles. So it's kind of, you can see it's kind of slanty. You can see that it has dashes, an equal dash all the way around, which means those sides are congruent, but there aren't any squares off in the corner because none of those look straight up and down like an L or a backwards L or 7 or whatever. So those are not squares, they are a rhombus. And the last one I want you to have the definition of is a trapezoid. And a trapezoid is simply a quadrilateral with only one pair of parallel sides. So if you stretch them out forever, they would only one set of sides would go on and not touch. These are the parallel sides. If you stretch these out forever, this way, these would never touch. If I stretch this one out, going up at that angle and that one, they're going to eventually cross. There are no dash marks, which means that every side is measured differently, and there are no little squared off corners, which means they consider this with no right angles. It can have a right angle. This one didn't. It's really supposed to kind of be angled out a little bit. I don't know if it looks that way for you. So that's the trapezoid. It has one set of parallel. On this particular one, it's the top and the bottom, and the two sides are not parallel. So there are some interesting little facts about some of these quadrilaterals that might come into play from one time to another. A rhombus can sometimes be a square. If we take the rhombus that has 4 equal sides, if we straightened it up, it becomes a square. So a rhombus can be a square because a rhombus only has to have 4 congruent sides. The next thing I wanted you to see was that a parallelogram can sometimes be a rectangle. Remember that rectangle has 2 opposite sides congruent, and they are all parallel. So this is just a very special kind of parallelogram. And it has to have right angles. This, on the other hand, is not. That is a parallelogram, but it is not a rectangle because those are not right angles here. Those are not right angles. A trapezoid is never a parallelogram because the trapezoid only has the parallel sides on one side or the other, not 4. So a parallelogram has to have 2 opposite sides that are always parallel. So a trapezoid is never a parallelogram. And also a square is always a rhombus, but a rhombus is not always a square. Okay, so that can be kind of tricky. But a square, remember, a rhombus simply has to have 4 congruent sides. So a square is always going to have that. It's just that what makes a square is that it has the right angles with it. So very shortly, we're going to look at some ways to measure these and get some more details about quadrilaterals.